Hello, welcome back to Stochastics Processes class. My name is Oludu Afengolugu. Today we'll be checking the step transition probabilities examples. So we have two examples. So the first example, we have a survey matrix, a survey of American. Okay. A survey of American car buyers indicated that if a person buys a Ford, there's a 60% chance that their next purchase will be a Ford, while owners of a GM will buy a gain with probability of 0.80. So find the following probabilities: the probability that a present owner of a GM will buy a GM at his next car, and probability that a present owner of a Ford will buy a GM as his third car, and the probability that a present owner of GM will buy a GM as his fourth car. So for simple solution, let's have the transition matrix. That will help us a lot. Alright, the transition matrix. We have the present purchase, or what we call the first purchase. We use the word the first purchase. We have Ford, we have GM. Then the second purchase, we have Ford, and then I call this the second purchase. So according to the question, we have if a person buy a Ford, there's 60% chance that their next purchase will be a Ford. 60%, that is 60 over 100, we have 0.6. That means there is 0.4 chance that they will get GM for their next purchase. So continue with the question, we have why owners of GM will buy again with probability of 0.80. And they will buy GM again 0.8. That means that there will be 0.2 probability of them buying Ford for their second purchase. And then with that, now we can now move to the question we are asked to solve. So question 1a said the probability that the present owner X0 equals to GM. Let me use the word G alone. We buy GM as his next car, that is S subscript 1. We buy GM as his next car, that is G. And that is the probability of transitions from the current G to G over step 1. So probability for moving from G to G, that is 0.8. I believe you get that. Okay, that is straightforward though. So let's check question 2. The probability that the present owner of a Ford first purchase Ford will buy GM as his third car. Don't forget X1 is the second part. Okay, let me just do a little analysis here. We have X0, which is the first purchase, S1, which is the second purchase, S2, which is third purchase, S3, which is third purchase. That is, this represents my first purchase, this represents my second purchase, this represents my third purchase, and this represents my fourth purchase. So now I'm asked to find the third purchase, the probability that a present owner of a Ford will buy a GM as his third car, which is X2. That is X0 to X2, that is over 2 step. X2 equals to G over 2 step. So the probability of transiting from F to G over 2 step. That means I'm going to find the square of my transition matrix. I have 0.6, 0.4, 0.2, 0.8 times 0.6, 0.4, 0.2, 0.8. So in matrix multiplication, you can check our previous lesson on how to engage matrix multiplication in our playlist. So you can also make use of your calculator. You have a powerful calculator to do that. So quickly, let's do the matrix multiplication of 0.6, 0.4, 0.2, and 0.8. So if we multiply this matrix, we are going to have we have 0.44, we have 0.44, 0.56, 0.28, and then 0.72. So now this now from first purchase to third purchase. Let me label it so that I have better understanding. So this is Ford, GM, Ford, GM. So this is our first purchase. First purchase. So this is our our third purchase. So now what we are looking for is a transition from our first to our transition from Ford to G. Transition from Ford to G. From Ford to G at the third purchase that we have 0.56. 0.56. The transition that our first purchase, the first purchase of the man is Ford, then his third purchase will be GM, that is 0.56. And lastly, let's check the next question. But the probability that the present owner of a GM will buy GM as his fourth car. So as his fourth car means X3. That is probability of moving from GM, transiting from GM to GM over step 3. GM, oh, this is GM to GM, but that's over step 3. Then we have to find the keep of our transition matrix. So we already have this to be our p square. So we just multiply that with p, following the matrix multiplication rule. So that's 0.6, 0.4, 0.2, 0.8. So probably if we do this, we are going to have 0.376, 0.624, 0.312, 0.688. Don't forget this is your first purchase, which is F of G, and this is now your fourth purchase. But what we are concerned about the transition from moving from G to G, that is 0.688. Alright, so let's move to the second question. Example 2. An interesting question indeed. So we have Professor A has breakfast at Lord Greenwich every morning. He either orders an egg or a bread. He never orders eggs on 2 consecutive days, but if he does order bread one day, then the next day he can order bread or eggs with equal probability. Question 1. Write a transition matrix for the problem. And question B. If Professor A has bread on Monday, what is the probability we have bread on Tuesday? And C. If Professor A has eggs on Monday, find the probability we have bread on Wednesday. And last question there we have, if Professor A has eggs on Monday, what is the probability he will have bread on Thursday? So let's go straight to the first question, which is the transition matrix. So you can also check our previous lesson on setting up transition matrix in the playlist of stochastic processes for better understanding. Since we are dealing with 2 types of food, that means we have 2 states. We are going to have 2 by 2 matrix. So the 2 type of food it takes is eggs or bread. You have eggs, you have bread. So this is Monday and this is Tuesday. Okay, so let's go back to the question now. So the question, he never orders eggs on 2 consecutive days. That means that if he order eggs on Monday, he's not going to order eggs on Tuesday, but he's going to move to the next one, which is bread. 1. Is that the thing? Alright. Also, but if he does order bread one day, then the next day he can order bread or eggs with equal probability. And we know that the summation of our probability should be 1. That if you order bread on Monday, you can either order eggs on Tuesday or bread on Tuesday with equal probability, which is 0.5 is 0.5, and this gives us our transition matrix for the problem. Alright, the next question is, if Professor A has bread on Monday, what is the probability we have bread on Tuesday? So then first of all, write out this process of this particular problem. We have Monday, we have Tuesday, we have Wednesday, we have Thursday, we have Friday, and then Saturday, and probably Sunday. So from Monday to Tuesday, that is over step 1, that is P. Then from Monday to Wednesday, that is over step 2, that is P squared, because we are jumping over T, which is Tuesday. From Monday to Thursday, that is P3. We are jumping, we are meeting Tuesday and Wednesday. And from Monday to Friday, that is P4. That's over step 4. From Monday to Saturday, that is P5. And from Monday to Sunday, that is P6. I believe you understand that analogy. So that will help us a lot. So let's now go to the question B. Let me change my pen. Question 1B, 2B now. So it should be 3. This is example 3. Alright. So if Professor A has bread on Monday, X not equals to bread, what's the probability we have bread on Tuesday? That is Monday, Tuesday, that is X1. Is going to have bread on Tuesday, which is B. That is transition probability from bread to bread. So let's see, from bread to bread, that will be 0.5. From bread to bread, that is 0.5. That is very straightforward. Alright, then to C, let's see the next question. We have if Professor A asks X on Monday, X not equals to egg, then find the probability we have bread on Wednesday. So let's do the counting. Monday, Tuesday, Wednesday. That is X2. And that is what is that now? Find the probability we have bread. That is B. This is egg. So we are moving from, that is over step 2, that is P square, or transition from egg to bread. So for us to get this, we have to first of all find the square of our transition matrix. And that is 0, 1, 0 0.5, 0 0.5 times 0, 0 0.5, 1, 0 0.5. So multiplying this, so following the matrix multiplication rule for 0, 1, 0 0.5, and then 0 0.5. So you can do this at your own hour and check the calculation properly. So I'm going to have 0 0.5, 0 0.5, 0 0.2, 0 0.75. So here we have our, don't forget this is Monday, and we have egg, we have bread, we have egg, we have bread. So this is now Wednesday. From Monday to Wednesday, that's over 2 steps. So this is our P square. So now what we are actually concerned about this question C is probability of moving from E to B over 2 steps. E to B, that is 0.5. So then the probability that Professor A will have bread on Wednesday, given that he has eggs on Monday, is 0.5. So let's check the last question. Question 2D. So probability, if Professor A has eggs on Monday, X not equals to egg, what probability we have bread on Tuesday? Tuesday, this is X naught, X1, X2, X3. That is X3 equals to, it's going to have bread on Tuesday and Thursday rather. That is over step 3. So probability over step 3, give them away from egg to bread. So for that now we need our P cube. We need to find our transition matrix and multiply it over 3. So we already have our P squared to be 0 0.5, 0.5, 0.25, 0.75. So just multiply with the transition matrix P, 0, 1, 0.5, 0.5. Then with that we have our result. Still being 0.25, 0.75, 0.375, and then 0.625. So our Monday is egg, bread. So our Thursday, egg, bread. This is Thursday now, but this is Monday. So we are now, the question is moving transition from E to B, which is this, and that is 0.75. So now moving from E to B over step 3, we have 0.75. So you can take your time to watch the video again and again for better understanding. Alright, thank you for watching. My name is Sondolo Afem Godogbe. See you in the next class.